This particular project put a lot of paving and a lot of structures on the site. In fact, they almost covered the entire site with paving or structures. So you're going to certainly have a lot of storm drainage on the site. Now here you can see the storm drainage pipe. And like the others, it has the lead to the city's main storm drain, which eventually leads to our streams and rivers. This storm drainage system also picks up the drainage from our roofs through gutter systems. So you'll need to figure out the size of the drainage pipes, the size of the catch basins, the elevation of those things. So let's look at the different type of drains on this site. They make use of trench drains on this site. That's where you have paving coming into a certain spot, and then there's a strip where that water flows into. That's a trench drain. We can see a detail of that here. And here's actually what one looks like on site. These are precast. You can set them in place, connect your drain lines to them, feed that into your storm drainage system. You have grate inlets, right? You're probably familiar with these. These are the catch basins that you have, and you have a grate over the top of them. Water flows into that grate. And here are a couple examples of those catch basins actually being installed. You can build them in place with block, or you can have them precast and set them in place. Now when it comes to the pipe between the catch basins, the elevation of that pipe, the elevation of the catch basin, the size of the pipe, all that really matters. And you can look all of that up in a schedule. So on the drawings, you're going to have each one of the catch basins numbered, and you're going to have a schedule to look up those catch basins, and it's going to be going from and to. And on that schedule, you're going to be able to see the invert elevation of the pipe and the size of the pipe on both ends of that pipe. Well, invert may be a new term to you, so let's talk about what an invert is. I always like to refer to an invert as the top of the bottom, because what you're concerned with is where does the water begin to flow, right? That's the top of the bottom of the pipe, or the top of the bottom of the catch basin. When you're looking for the invert of the catch basin itself, you're looking at the top of the bottom of the catch basin. You're not talking about the part that's hitting the soil, you're talking about the slab on top of that. That's the invert. If you're looking for the invert of the pipe, it is the top of the bottom of the pipe. So you can have an invert of a pipe coming into the catch basin. That's water flowing in. You'd want the invert of the pipe going out of the catch basin to be lower than that to make sure that water flows downhill. Here's an example of a stormwater profile that is not in CapBus. I pulled this from somewhere else. But it gives you a great illustration of how the stormwater system works. They exaggerated the vertical quite a bit to really show how this is flowing downhill. But notice that at the top of each catch basin, they show you the manhole top, they show you the inverts of the pipe coming in, the invert of the pipe going out, and they make sure that it's all going to flow downhill.